Hello and greetings to you, Sir Mama Fauzi. Welcome back again to our presentation this time. So, how are you? I'm hoping that you are having a very wonderful and great day today. So, today again, we're going to present about our Geotechnical Engineering and Highway Laboratory DCC 30112. So, the topic for our presentation today would be Laboratory for Atterberg Limits. This presentation will be presented by our Group 1. So before we're going to start to our real presentation, we would like to introduce ourselves first as usual. As the first group presenter, my name is Federick Sarek Anak and my matrix number is 05DKA20F1041. And alongside with me are Jason Anak Mong, Bronny Malantika Anak Gret, and last but not least is Dominic our Anak Joannes. So without further ado, let's take to our real presentation about Atterberg Limits Laboratory. As you know that we're having this Atterberg Limits Laboratory is for us to know the liquid and plastic limits for our laboratory test. But before that, we need to know the aim of the experiment or test first. So this is the aim of our Atterberg Limits Laboratory is to determine the liquid and plastic limits of a given soil sample. So as you know that every test or laboratory that we are having through, it is all depends on the soil sample. We need to have the soil sample first. So we need to know the types of the soil. We need to define the soil first. We need to know the characteristics of the soil. So yeah, that's the aim for our Atterberg limits.
Hello and greetings, sir. My name is Jason Mong. Today I'll be presenting Atterberg limits about liquid limit. So without further ado, let's start the simulation. And first, add a container from the apparatus menu. So we click on the container in the apparatus menu to add the container on the workspace. So next we add a soil sample and water to the container from the apparatus menu. So click on the soil sample, and we must assume that the soil was previously sieved and air dried and then pulverized. So as for the next part, I'll be pass it to Dominic our Joannes. Thank you.
Hello, sir. My name is Dominic Joannes, and I will continue for the further step of the Atterberg limits. Alright, for this step, we have to add water inside the container with the soil. So we have to mix the soil and the water to make it into a uniform paste. So by clicking on the soil, we made a uniform paste soil. Alright, for the next step is by clicking the Cassegrain apparatus. So this one, we move the soil, this one, to the Cassegrain apparatus. So we move the soil, and then we click on the Cassegrain apparatus to cut clean straight groove down the center of the soil pad using a grooving tool. So we the cut clean the soil by clicking it. Then we rotate the cup by clicking on the apparatus, I mean the Cassegrain apparatus, approximately 2 drops per second, and count the number of drops or the rotation it takes to make 2 halves of soil pad. And lastly, we take the sample soil using a spatula. Then from this graph, as you can see right here, we have to observe the corresponding obtain and derive the liquid limit value by taking the water content of 25 drops. So this one for the graph observation, we use it for the next report. So that's all from me. Thank you very much.
Hello everyone, my name is Bronny Malantika Gret. Okay, I'm gonna present about the Atterberg limit. This is for plastic limit. Okay, for the instruction, okay, the first instruction we from this virtual lab that has been given to us by our lecturer, Mr. Pauzi. Okay, for the first instruction, click on container in the apparatus menu to add a container to the workspace. Okay, we click the container, and then as we can see for the diagram, okay, then for the next step, which is click on soil sample in the apparatus menu to add a soil sample to the container. Okay, then click on soil sample. Okay, then click on water in the apparatus menu to add water to the soil fill in container. Okay, click water. Okay, these are for my part. Next, I would like to pass this presentation to the second person, which is Federick Sarek.
After that, for our next step is now we have our water in our soil sample in our small container. All we have to do is mix it up, take out of our glass plate, take out of our soil sample just now that we have mixed with our water, take it out and put it onto our glass plate and spread it. Okay, all we have to do now is we need to roll it again and again and again, and make sure it reach into 3 millimeter of diameter. And after that we need to cut it off into maybe 3 to 4 partition. So take out one of the partition just now, and then we calculate it into our data. So this is our data that we have take from the partition is now of our soil sample, the observation for sample, observation for our content in percent. Okay, so all of this data we need to put it into our report. Okay, so this is the laboratory for our Atterberg limits presentation. I think that's all from us for our presentation. Okay, thank you, sir, for your time. I'm hoping that you're enjoying your day. Thank you for listening to our presentation for our Atterberg limits laboratory. And again, my name is Frederick and I'm the last presenter. Thank you, sir.